Welcome back. We're going to do another Wireshark video today. Today we're going to follow the TCP stream. When we follow the TCP stream, during the initial connection between a client and a server, there forms a connection between the two. And so because of the way the TCP works and the constant communication for error checking and flow control and all the little requirements that TCP has, we can actually see the communication or the connection-oriented command that's going between the client and the server, and we can track that. And that's what we're going to do today. So we just need an HTTP. I'm actually going to sort by HTTP today. I'm going to throw that filter in there. I'm going to find one at random. I'm just going to grab this one right here. This one looks good. I'm going to right-click. I'm going to go down to follow, and then I'm going to follow TCP stream. Not HTTP stream, TCP stream. And you'll notice that in this case, there really isn't that much. So I picked a really bad one. Let's see if we can't find a better one this time. Let me go ahead and get rid of this again. We'll pick up something a little bit better. Let's find a different one. Let's look at this one right here. Again, follow, TCP stream. There we go. This is a good one. This one shows us some different aspects of what's going on. Now, you'll notice that it's color-coded. The first part is red. Now, this is our client. And we can see the client talk to the goat.com using Mozilla 5.0, connecting to a Linux system, right? Or actually on a Linux system, excuse me, using Firefox, which we knew it was because of Mozilla. We can see that it's looking at different aspects of it. We can see the refer, that's the server it tried to connect to, is the goat.com. And we can see all that. This is all client information in red. Then we look at the information in blue. This is the information from the server. And we can see based on that it is running currently, best guess scenario, Apache 2.2.8 on an Ubuntu machine, which tells us that it is a Linux. Now, be careful with this, right? We know it's an Ubuntu, but that's a best guess. A lot of times, we're not going to be able to figure out the operating system. And following the TCP stream doesn't really tell us what the operating system is. It takes a guess for it, but that's not something that's normally part of the TCP stream. It tells us what the server is, and we know that the software on the server for interacting with it is Apache 2.28. But as far as the Ubuntu goes, we're not positive that's actually reliable information. Next, we have expires. And when we talk about the expires, we can see this one expired on 19 November 1981. There's really three different options for the expires. There's a future date, in which case the date specified expires somewhere in the future, and we're good to go. There's no problem. There's a past date, which is what we're seeing here, and this is where the resource is considered to be immediately stale, and the client should request a fresh copy. We should request a new version of the current information that's provided on the web server. And then there's no cache. And with a no cache, there is no expiration date. This is just the normal where, hey, we don't really know what's going on. Usually we'll have a future date or we'll have a past date in the cache where we need to identify what's going on with that perspective. In this case, 1981, quite a bit of ways away considering that this PCAP file was taken for 2024. So, but you know, hey, that's what happens when you use an older system in your VM to figure out what's going on. The next thing we want to take a look at is the content type. Now, the content type is located right here, and it basically provides the server response. The server can respond in a variety of different ways. It could provide us a PNG file. It could provide us an HTML text like we see here. It could also provide us something called OCSP, or Online Certificate Status Protocol. Regardless of what it provides us, you need to understand where it's located, and the content provides that information. Now, if I scroll down a little bit here, you can see an E tag. The E tag is located right here, and that provides us some important information as well. This allows us to identify whether or not the web page or the site has changed since the last time we visited. It's sort of like a blueprint or a fingerprint for the web page. We store that information inside of our browser, and then if we visit the website again, and the E tags don't match up, then we know that we need to refresh it. And that's pretty much all the E tag provides us. So we can kind of see as we go through this, the different information that's associated by following that TCP stream. For instance, we can find out that the original information for the original HTTP was www.w3.org from 1999 using XHTML. And we can actually find different contexts. For instance, we could see Cure Words, Lotus CMS. We can find different link information that was browsed. It just gives us an overall hierarchy, or overall view, I should say, of what the website was visited and the different traffic that was passed back and forth between the client and the server. And the final thing I want to show you before we move along to our next video is length. Now, we talked about the timestamp and how you can move time around, but we never really talked about the different aspects of it. You have to remember that our source IP address is located here, destination is here, and we can actually find the different port numbers associated with it. For instance, 192.168.56.101 is using port 33628, and that's why we have this column. It makes lives a little bit easier. However, our destination port is slightly different. That's port 80, and we know that operates on HTTP, if you can remember that from your studies. The final thing, however, is this link. Now, this link tells us how many bits or how many bytes were associated with the traffic at the time. If I go through and I get rid of this little number right here and I press enter, now if I wanted to see the largest packet within my system, I can actually sort by byte length. If I hit this byte length thing right here, it'll start to sort it. Now, instead of scrolling all the way up or down, I can just hit this little button at the very top. It'll go to the last packet, and I can see that the largest packet that was on my Wireshark PCAP was 2,964 bits in length. If I go to the first one, I can see the shortest was 44 bytes. Now, when that comes into it, probably not that impressive, but you may get a question asking about specifically about how long a packet was or the nature of it. I can also sort this by a specific filter. So if I type in HTTP again, I can sort it again, go to the very farthest, and I can see that my largest HTTP packet didn't change. It's 2,949 bytes. If I want to see the smallest, it's actually 86 bytes. And that's just by sorting by length. Remember, don't be afraid to use these little columns at the very top to sort the traffic in a way that you need to. One of the greatest powers Wireshark has is its ability to sort through data very quickly and very efficiently in a way that you need it to. That's it for me for today. We will see you next time when we explore even more Wireshark, or you can hit my upcoming video where I believe we're going to do a little bit of offensive security. So I've got that coming up as well. We'll see you next time. For now, I'm Dr. K. Have a good one.